The greenhouse effect as seen in terrestrial planets. Surrounding the Earth is a layer of atmosphere which receives sunlight. The atmosphere is made up of greenhouse gases such as water vapor and carbon dioxide. As sunlight hits the atmosphere, 31% of the incoming sunlight is reflected back into space. Thus, the remaining 69% of incoming solar energy is absorbed by Earth. Absorbed sunlight heats the surface. Heated surface emits infrared radiation. If there are no greenhouse gases to trap the radiation, it could easily be leaked back into space. The infrared radiation that is trapped by greenhouse gases heats both the surface and the atmosphere, thus increasing the average temperature. Earth's perfect distance from the Sun allows the presence of oceans in which CO2 can be dissolved in, so the atmosphere is not overwhelmed by CO2. Plate tectonics and volcanoes allow CO2 to be outgassed back into the atmosphere. On Earth, temperature would drop by 33 Celsius without the presence of CO2. Let's see the consequence of the greenhouse effect in other terrestrial planets. Notice how the planet's size and distance from the Sun factors into the phenomenon. Mercury has no atmosphere due to its small size and therefore has no greenhouse effect. Without the greenhouse effect to trap heat, nighttime temperatures are drastically different than daytime temperatures. Venus's atmosphere is hot and dense due to the runaway greenhouse effect. CO2 and sulfur combined with other elements was initially outgassed and dissolved in oceans similar to the Earth. But because of Sun's energy output increasing over time and Venus's close distance to the Sun, temperatures rose, which evaporated oceans. More CO2 and sulfuric acid was in the atmosphere because it could not be recycled. Therefore, more greenhouse gases led to increased temperature, which evaporated more oceans, which led to more greenhouse gases in the atmosphere, trapping more heat. This ongoing cycle is known as the runaway greenhouse effect. The atmosphere is so massive, with 96.5% CO2, that once heated by the Sun, it retains its heat throughout the long night. Thus, the temperature during the day and night are around 460 Celsius. If all the CO2 were to be eliminated, Venus would have been 400 Celsius cooler. Mars's atmosphere is cold and thin due to the runaway ice house effect. Mars's greater distance from the Sun decreases sunlight and thus decreases the temperature to condense H2O into rain. Since Mars is small, it was cooled easily and volcanic activity was eliminated, which reduced the outgassing of CO2. Less CO2 in the atmosphere reduced temperature even further, which condensed more water for CO2 and SO2 to be dissolved in. Although the atmosphere is made up of 95.3% of CO2, the Martian atmosphere is so thin that the greenhouse effect is weak. The small thermal insulation explains the large daytime and nighttime temperature differences. Without CO2, the temperature would have only decreased by 5 degrees Celsius. Now we know the consequences of the greenhouse effect on terrestrial planets, we can see how important balance is. Too much CO2 may cause our planet to become like Venus. Let's all work together to create the beautiful Earth we call home.
Created using Powtoon.